All right, so today is Tuesday, March the 1st. It's Women's Month. Mhm. Number one, the first thing that we're going to do is our warm up. Give you time to do your warm up. Then I am going to go over polynomials with you. Um, in order for us to be able to solve quadratic functions, we have to understand how to add, subtract, multiply, and factor polynomials. So we're starting with adding and subtracting polynomials first, but there are some things that you have to know about polynomials before you can just add or subtract. So today is going to be an intro to polynomials. And hopefully we'll get to do the addition and subtraction of polynomials today. If not, that's okay. So we possibly have guided and independent practice. Okay. Um, Tuesday homework. Make sure that you review or study your notes. Don't wait until we get to a test to start reviewing. All you need is about 2 minutes to look over notes. I mean, don't take that long. Just look over it, make sure you understand it. If you have questions, then that's what you ask me about in tutoring, okay? Do not forget that you do have virtual tutoring here on Wednesday. And that's at 3 p.m. So don't forget about that. If you need another date and time, please text me or email me to let me know you need another date and another time. Okay? Let's write in our planners, please. I'm going to write your stuff in blue. We're in week 6. The quarter is more than halfway over. That's crazy. All right, so we got math 1, homework. We need to review our notes. Okay. Go back to the previous day. Please check off if you have completed the math 1 homework, and you should have already completed the test. Check those things off. Okay. Any questions, comments, or concerns? All right. Okay. Before I make a decision, the homework. Were there any questions about the homework? Do I need to make a homework help video for anything? Please speak now. Forever hold your peace. Yes, baby.
Is today like the cutoff line for the progress report?
Today, before progress reports, I would print either today or in the morning. So yes. So get as much turned in as you possibly can. Okay. Before progress reports go out. If you did it after, then of course it's not going to be on the progress report. I mean, your grade will still be updated, but you won't have a printed copy of your updated grade. Okay. Any other questions? All right, let's work on our warm-up, please. Okay, you didn't respond. Did anybody need a homework help video for any of the topics this week? All right, I'm going to pause for the calls and give you a chance. I'm going to check your homework. Please make sure that you're working on your warm-up. Okay, so let's look at the warm-up. It says Amy is making an initial investment of $5,000. The investment loses. It loses 13.5% each year. Guys, come on. Do you have a question for me, though? Okay. Find the final amount Amy has at the end of 8 years. Okay, so what kind of, we know it's exponential function because it's growing by a percent. Is this exponential growth or decay? Yes.
It's growth.
It's growth. So what formula do we use? Donnie? C is y equals c. That's okay. Parentheses, not plus, minus because it's decay. And then to the x power. It's decay. Loses. It loses 13.3%. All right, so now what's gonna be our C here? Yes. 5,000. 1 minus, how do we write our R here, Kyle?
You move it like 2 decimals to the left.
Okay, and so what's that going to be when you move it?
0.125.
Very good. And to what power are we going to do here? 8, because it's 8 years. Okay, so you type this in and you see what your dollar amount is going to be after 8 years. Any questions?
No.
Okay. All right, let's look at the Tuesday one. This is where you have a table. The height is X and the shoe size is going to be Y. Okay. And so you have got to do a line of best fit. So your line of best fit, you go to stat, edit. Let me clear second plus 712. Clear my calculator. Then stat edit. And then I type in my X values in under L1, which is going to be 67, 70, 70.3. I'm sorry, 70.5. Then 75, 78, and 66. Go to, I messed up on that one. 78. And then 66. Okay, and then we have 8.5, 9.5, 11, 12, 13, and 8. All right, where do I go? After I type my numbers in the calculator, where do I go from there? Yes. I go to stat, calc, lean rig. Okay. And then I write that equation here. Okay, how do I do this part where it says if a man's shoe size is 10.5, then predict his height? What am I going to do to figure that out? Yes. Okay, I plug in, this is the shoe size. So you're going to actually plug this in for Y because the height is X and the shoe size is Y. Okay, so when you plug it in for Y, it's a regular equation and just solve for X. All right. Any questions or concerns? Yes, babe.
Don't you still have to do the L1, L2 and the Y bars function?
You can, if you want to look it up in the you can.
Okay.
Yeah. All right. Any questions? All right. Good deal. Let's go ahead and put this up. Anybody still writing before I move it? Okay. I'll pause. All right. Let's go to the last page in which we were on. And that was here, intro to quadratics. Intro to quadratics. Okay. I want you to quickly look over your notes. I'm going to give you about 2 minutes. Then we're going to do something with that. All right. With your white piece of paper, turn it this way. And we're going to make 3. We're going to make 3 columns. Shh. Please hush. This, you can if you want to. It's perfectly fine if you want to. This first column is linear, exponential, quadratic. Okay, I'm gonna ask you questions about all 3, and then you put the answer in. I'm gonna collect this at the end. Okay? Yes, baby. You got a question? Oh, I thought you said you had a question. I'm sorry. All right. For each one of these, in this first, I'm gonna draw a box all the way across. For this first box, I want you to give me some examples of what a linear equation is. What does it look like? I need 4 different kinds of lines. Pause for the cause. All right. For exponential function, there's two different kinds of exponential function. Graph what they look like.
Do you put the name of them?
You can. And they're the same for quadratic. There's two different types of examples of what a quadratic function look like. Draw those as well. All right, in the second box, I need you to write the definition, what you think it is, what do they do. So these are the definitions. What is a linear equation or function? What is an exponential equation or function? What is a quadratic equation or function? Definitions. Okay, this is the last box here. I need, bless you, babe, all of the equations and forms that these equations can be written in. So I need all the different forms that an equation can be written in. Okay, I'll give you one for this one, the slope-intercept form. For linear functions, it's going to be y equals mx plus b. That's the one I'm going to give you. Okay, so there are others. All that you can think of for linear, exponential, and quadratic. Look at this. Please watch, because I'm going to do this with you again. I'm just going to add more stuff. For linear, you have positive slopes, straight line, negative slope, straight line. You have undefined slope, that's a vertical line, and horizontal line is zero slope. These are different kinds of examples. For exponential, it's exponential growth, where a curved line is going up, exponential decay, where your curved line is going down. For a quadratic function, you have U-shaped line. This is an upward parabola. This is a downward parabola, okay? And it doesn't have to be in the center. It can be off to the side. It can be upward, A linear function is an equation or function. I'm just going to put an equation that graphs straight lines. Raise your hand if you got that right. Okay, good. They graph straight lines. All right? Exponential function or equations or functions is an equation. What kind of lines do these graph?
Curved.
Graph curved lines. They also grow or decay by a common ratio. Grow by common ratio or what?
Exponent or rate.
What's the rate called? Percent. Okay, what's a quadratic function? Is an equation that what? Very good. All right. So what are some other forms that a linear equation can be written in besides the slope-intercept form? Yes.
I said the standard form.
The standard form? What's the standard form for a linear equation?
What is
Mm-mm.
AX plus
by is equal to c. Okay. Another thing is you're starting at, you can do recursive. Starting at next equals now, and it's plus or minus whatever the now was, okay? This is recursive formula, all right? Okay, what about exponential? What are some forms for exponential function? Yes.
I said exponential growth.
Okay, let's start with the basic one. Let's start with the standard form first. What's the standard form for exponential function?
Y equals A times B to the power of X.
Very good. Okay. And then you said exponential growth, right?
Yeah.
And what's the exponential growth formula?
Y equals C. Parentheses 1
plus R.
Okay. And what's another one?
Exponential
Exponential decay. And what's exponential decay?
Y equals C, parentheses 1 minus R to the power.
Okay. What's another one? Starts with a C. Mhm. Compound interest. Okay. What's the formula for compound interest?
Y equals C parentheses
Mhm.
parentheses 1
Or the letter that you can say C, or what's the other letter? P.
1 plus R over N to the nth power.
Okay. And what about quadratic? What about quadratic? The standard.
Y equals AX to the second power plus BX plus C.
Very good. Y is equal to AX squared plus BX plus C. A, B, and C are numbers, okay? This is the part that makes it a quadratic function. All right, I'm going to ask you these questions again, so please make sure that you know this stuff by heart, okay? All right, take out your notebook. Take out your notebook. We're on page 22, okay? And this is going to be polynomials. I forgot what page I said this was. 22?
22.
Thanks.
I can't believe it's March already.
Me either.
We're already halfway.
More than halfway. All right, let's look at it. Yes, ma'am. You got a question? Oh, are you saying yes, ma'am? Oh, okay. All right.
He says that about every 30 seconds.
He does, and I forget sometimes. That I'm like, what is he saying? I'm thinking he's asking me a question or something. Okay, I get it. All right, it's respectful. I get it. All right, so we got polynomials. Um, in order, and I said this earlier, but in order to solve problems dealing with quadratic functions, you must fully understand how to add, subtract, multiply, and divide polynomials as well as factoring them. Okay, so you must fully understand the following. Okay, but while it seems like we're jumping to something else when it's all going to connect in the end after you know what you're doing. Okay, you have to fully understand how to add, subtract, multiply, and factor polynomials. So we've got to fully understand what a polynomial is, okay? I'll give you a chance to write. Let me pause for the calls. All right, the first thing that we need to know about polynomials is what is a polynomial. Does anybody know what the root word poly mean?
More than one.
More than one. Yes. What's your question, baby? Are you going to answer?
I was gonna say, like, isn't there a shape like a polygon or something?
Yes, a polygon has many sides. So poly meaning many or more than one, okay? So for this one, a polynomial is an expression with more than one term, okay? Okay? Terms are separated by addition or subtraction signs. So I'm going to put a semicolon because I'm going to add to this. Terms are separated. Oops, sorry. By an addition or subtraction sign. Okay. And then over out here to the side in this little bubble, we're going to put poly prefix meaning many. Like you all study in social studies polytheism, right? What is that? The worship of many.
More than one God.
Yeah, more than one God. Mm-hmm. Yes, baby.
What did it say under poly prefix?
Prefix meaning many, just means many, more than one. You can put that down. All right. So now we have my monomial. A monomial is one term. Again, your one term, an example of that, and put this is example. It could be a single number by itself. This is one term. It could be a variable by itself. It could be that you have a variable, a coefficient, and a variable right next to each other. That's still considered as one term. Okay. Any questions about that? Okay. Some people aren't realizing that even whatever number, even a fraction, can just be one term. Okay. Yes, baby.
Could multiplication or division separate terms?
No, just because this right here, that's a great question. This right here is multiplication, but it's only one term. So terms are only separated by addition signs or subtraction signs. Very good question. All right, now we got binomial. How many terms is a binomial? Two. Okay. Again, your terms are separated by an addition or subtraction sign. So look, an example of that could be n plus 1. This is two terms. It's separated by this plus sign here. Then you have, put a comma. Let's do another expression. 3x plus 7p. These are two terms separated by, let's put a minus sign here instead. I don't want you to get the impression that it has to be a plus. It can be plus or a minus. And then you might have 1/2 x, this is one single term, minus 16. Okay? This is also a binomial. It's two terms. Terms, again, are only separated by addition or subtraction signs. Angel, you okay?
Yeah.
Make sure you put your laptop away, babe. Thank you, sweetheart. All right. Now we have a trinomial. What's a trinomial? Three terms.
Would a decimal be one term?
It would be like 0.582. That's one term. So this is going to be 3. I put 2. I'm sorry, y'all. My mind is crazy. 3 terms. Okay? We're going to do some examples of that. I'm going to put this down here to give some space. All right? So we could have 7n to the second plus 8n minus 16. Okay, Ms. Reyes, these are 3 different terms because you can't combine these 2 terms together. I can't combine these 2 terms together because this is saying I have 7 n squares. And this is saying I have 8 just n's. They're not like terms. The only way you can combine variables together is not only does it have to be the same variable, but the same exponent has to be attached to that variable. If they're different exponents, you cannot combine them together. Any questions about that? So this is 3 terms separated by an addition and subtraction sign. Another example could be a negative 16nw. You see how it's two variables here. That's still one term because this is multiplication. This is one term. Separated by a subtraction sign. So that's minus 11 plus w. These are 3 terms. This is a trinomial. Any questions about that? The most important thing to memorize is that binomials, trinomials, because it's more than one term, they are going to be polynomials. A monomial is just one term, so you don't consider a monomial as a polynomial. Yes, baby. This way or the other way? Is that better? Okay. So a polynomial or polynomials, more than one term, therefore by a binomial and a trinomial, binomials and trinomials are polynomials. Okay, I probably should put a comma here. A monomial is not a polynomial. Any questions about that? Yes, baby.
So if you had like 2 n terms, could you combine them together and it would still be a trinomial?
If I had 2 numbers that could be combined together, then after I combine them, it becomes 1 if I can combine them together. Very good question.